All right, hi kids. So today what we're going to do is we're going to build quadratic models using problems, and within the problems we're going to basically build our first quadratics from scratch. So I apologize for not being here. My daughter's sick, so I'm on dad duty today. Anyway, what you're going to need is you're going to need to take out your textbook, and we're going to do some problems actually in the example part and in the homework part. We're going to kind of jump around. Just make sure you're on the right page. With this being our first video lesson, be sure to pause, rewind, replay as many times as you want. This is yours from here on out. So if you're not understanding anything, just repeat it. This is a tough lesson for me not being here, so I actually had it already written out. So I'm not actually going to write anything. I'm just going to kind of scroll through it because my computer doesn't really write that well from home. So I'm just going to scroll down and I'm going to try to highlight certain things to emphasize in certain parts. So just make sure that you're ready to go with these things. So here we go. So page 73. So it's going to start from easy and go to hard. All right, so here we go. Page 73, example number 2. Let g of x equal 3x squared plus 4x minus 36. What is g of 2? Well, here's the deal. This, like we've seen before, is called function notation. Usually you see it as f of x, but you can see it as g of x also. You can see h, k, whatever. All right, but this right here, when you see what is g of 2, all right, g is talking about the function. 2 is telling what we want to evaluate x to be. So if they tell you what x is, in this case it's 2, we're going to substitute the 2 into your problem for x. You're going to substitute it in here, and you're going to substitute it in here. And you can type it all in your calculator, or you can do PEMDAS and say, all right, 3 squared is 4, 4 times 3 is 12. So you'd write maybe like a little 12 up here. If you're going by hand, this is 12. All right. 4 times 2 is 8. All right. And then minus 36. So then you go 12 plus 8 is 20. 20 minus 36 is negative 16. So this g of 2 equals 16 is actually a point on the graph. It would be 2, 16. This is your x value. This is your y value that we solve for. And sorry, this needs to be negative 16 here. Negative 16. All right, so it's your coordinate, 2, negative 16. Let me put that in purple so you see it, negative 16. So there we go. Number 3. All right, so this is number 3, right after number 2. So it says the product, which is multiply. All right, so the product of 2 consecutive odd integers. So consecutive means numbers that are right next to each other. Consecutive odd integers. So that would be like 1 and 3. Or, I don't know, choose a number. 7. And a consecutive odd means the next odd number, which would be 7 and 9. Or pick a crazy one. How about 115? Its consecutive odd integer would be 117. Those are 2 consecutive odd integers. Anyway, so it says the product, when you multiply 2 consecutive odd integers together, its product is 2,915. Build a function that can be used to solve for the integers. Well, what are the 2 integers? Here we go. So when doing this problem, all right, or any problem like this, when you're trying to determine, you could do 2 ways. You can guess and check, and believe it or not, you could actually get that relatively quick. Or what I would like you to do is start thinking of quadratics. And what I mean by that is make the first number x and make the second number x plus 2. And think about it this way. All right, think about it. If we made 1x, how would you get to 3? You add 2. If we make 7x, how do you get to 9? Add 2. You would add 2 to it to get to 9. If 115 is x, to get to 117, add 2. So if you see, to get the second integer, you're just really just going x plus 2. Whatever the first integer is, you add 2 to get to the next consecutive odd integer. So what we're going to do is we're going to take the product of these 2 numbers and set them equal to, what we said was 2915. You see that? So when we distribute, we're going to get x squared, because x times x is x squared. X times 2 is 2x. And we're going to set it equal to 2915. Now here's the thing. All right. This, what we're looking for, what are these two odd integers? These two integers are x intercepts. C-E-P-T-S. That's what we're looking for. So what we need to do is we need to take this function, and this is our first time actually having to deal with a function like this, and we're actually going to have to put this in our calculator. And what I mean by that is, in order to put it into your calculator, it must equal 0. Because 0, when it equals 0, we can put this function in our calculator. So that means we're going to have to subtract by 2,915, move that over to this side, subtract by that over here, and we're going to get our new function to be x squared plus 2x, which we had here, minus 2915 equals 0. This is your new y value. And why I say it like that, why, is because you're going to put this sucker in your calculator. Oops, I already showed you the answer for y. So we're going to go x squared plus 2x minus 2915. Now, here's the deal. If this is in standard form, you should get a freebie here. And the reason I bring that up is because if you go to your window and you look at it, your window should be set to standard window of -10, 10, -10, 10, which means you're only seeing 100 pixels. Okay, how do you see more? Well, first off, if you look at your y-intercept can actually help you see how big your function is going to be. Well, in standard form, your y-intercept is your freebie. So our y-intercept is -2,915, meaning we're going to want to go to our window and make sure our y minimum is at least -3,000, because you want to make sure you see the y-intercept. And some of you are like, why? We want the x-intercepts. Well, that's going to kind of give you an idea of how far you want to go. Now, because I've done this problem before, I'm going to make my x-min and x-max -60 and 60. And you would have known that as soon as you graph this and you can't see your x-intercepts, which is what you want, you're going to make them bigger and make the x-minimum bigger as well, a bigger negative. So additionally, I'm going to want to see a larger y-max also, because I want to make sure that my graph, when I find my x-intercepts, I can go above and I can go below. So I'm going to make my y-max 1,000. And when you do that, boom, you should see this. Now, with our graph like this, we can now go second trace, go down to 0, and we can calculate our y-intercepts or our x-intercepts. Now, here's the deal. You want to find your left bound. Now, it doesn't matter, this x-intercept or this x-intercept, it does not matter. I'm going to start with this x-intercept. So I hit enter here, left bound. Now I need to be up here above the x-axis. So I'm going to have to click this about 1,000 times, hopefully not too many. And that's above, so I'm good. Hit enter, and I get an x-intercept of 53. You see that? That is my x value. You see that? Now, I'm going to write that down. X equals 53. We'll talk about that in a second, but we have two x-intercepts, right? So we got to find the other one. So I'm going to go second trace, go down to 0, and now I'm going to go and try to find the other x-intercept. Now, the reason you want to do that, and some of you are like, well, can't we just use the axis of symmetry here? Well, here's the deal. You don't actually know where your axis of symmetry is. And then if you're like, well, I think it's the y-intercept. Well, you're kind of guessing. We're not 100% sure, and you could calculate it, but I'm not going to calculate it. I'm just going to use my calculator to find my x-intercepts. I don't want to determine, is it the axis of symmetry, the y-intercept, and all that good stuff. So back over here, I'm going left above, and now I'm going below for right. Hit enter, and I get another x-intercept of -55. Now, here we go. I found both of them. So here's the deal. If that's what x is, how do you find your second integer? Well, you add 2. So if x is 53, the second integer would have to be, and I have them right here, 55, because 53 plus 2 is 55. And if you have -55 as one of your integers, add 2 to it, and you get -53. And that's how you do it. So you set up your first quadratic function. using 2 consecutive integers. Now, some of you are like, good Lord, Mr. Quadman, I guessed and checked and I figured that out quicker than you did. Well, here's the deal. You probably didn't find both pairs because technically there are 2 sets of odd integers that will give you the same 2,915 before you subtract it over. Pretty cool. Awesome. Here we go. Next example. Now, some of you are like, wow, that dude just talked really, really fast. I'm not following. Well, you can pause, rewind, replay, and you can watch it later too if you're struggling. Now, here we go. Number, I don't know which one this is, but it's from the homework, page 74. I believe it's example 6 and 7. So it says a museum curator needs to frame a rectangular painting. Their painting is 24 by 16. Now, here's the deal. Because I had already done this, unfortunately, you're going to see everything. But I want you to know this 24 by 16, all right, this 24 by 16 right here, this is actually going to be the black painting you see right here. This is it, right? Oops, man, my computer does not like me. This right here. There's your original painting. You see that? Now, here's the deal, all right? The first question it says is, if the frame is to be X width, so a width of X, what is a function for the area of the painting, including the frame? So we want to know what the new area is. So I'm actually going to put a different color. I'm going to make that green. So the area of the painting and the frame means that we're going to take the painting here and the frame here, and we want the total area. So everything, the frame and the painting included, and everything in the middle. You see that? So here's the deal. What we're going to do is we're going to take our painting of 16 by 24, and we're going to add an X width on both sides, X and X, and a height of X on both sides. All right, you see this? You got X, X, this is X here, this is X, and this is X. So you have a width, a height, and a width over here. Meaning that if we were to calculate the entire width going across, let's start with this. If you start at the edge of your frame to your painting, that's X. Plus, now your painting's 24 inches long, so plus 24, and then plus over here, once you get to the end of your painting, you have another X, so you got to go plus X. So up here, I have a simplified value. For our width, it's 24 plus 2x. That's your width, 24 plus 2x's of your frame. Now the same thing for your height. If you start from the bottom and going up, you have a width of x for the frame going around. Then you have 16 units for your frame plus another x. So you're going to go x plus 16 plus x, which is 16 plus 2x. So the area now of the frame and the painting, everything inside, is going to be 16 plus 2x times 24 plus 2x. So that's going to look like this. 16 plus 2x, 24 plus 2x. And then to find your total simplified area, you'll double distribute. So 24 times 16, 24 times 2x, 2x times 16, and 2x times 2x. And you're going to simplify this to get 384 plus 48x plus 32x plus 4x squared. Now, this 4x and 32x can combine, they're like terms, and you get 384 plus 80x plus 4x squared inches squared. Pretty cool, right? So now, that's your total area. Boom. Now, notice how I flipped it. You always want to make sure that you write it in standard form. Standard form, all right? So there you go. That's your total area. Now, ready? Part 7. What would be the area of just the frame? So just the frame, not the picture inside of it, if the value of x was determined to be 2.5 inches. So if we want to know just the frame, so this is what you're going to have to do. So think about it, all right? If we want the area of just the frame, let me take this green out, all right? If you have all this and you want just the frame, that means we need to remove, and notice how I'm kind of saying it, I'm spoiling it. You need to remove, oops, I got rid of that. I didn't want it. You want to get rid of all of this middle part. You want to get rid of all of the middle part here. So what I'm going to do is I'm actually going to just say, okay, you have this, and really all you want is this right here. So that's all you want, just the frame, no picture included. So how do you do that? Well, if we know X is 2.5 inches, we're going to first take the area of the picture, which we know to be 24 by 16, which is a total of 384. That's the middle, 384. Then, if we don't want the middle, we want that picture removed from here because we just want the frame, we're going to take our total area, which we just found in part problem 6, minus the picture, which is this right there, 384, and that's how you get the area of the frame. So, total area, again, everything, when we did it, was 4x squared plus 80x plus 384. By substituting in this 2.5 here, we can get a value of 609. 609 inches squared is everything, picture and the frame. But we don't want picture in the frame, we just want the frame. So we go 609 minus 384, which is the picture, and you get 225 inches squared. That's just your frame going around with a width of 2.5 inches. So there you go. That's a fun one right there. All right, here we go. Now, number 10. Now, this is where it could get a little confusing. I'm not trying to give you ammo for why you don't understand this, but this one is a little tricky, so you just got to think about it a little bit. So page 74 of your homework, this is number 10. I believe it's at the bottom. Now, if you're like, man, I'm running out of space here, I don't have anything, find some empty space, find an empty page, and you could take some notes or do some of these examples on there. So here we go. A family just bought a puppy and wants the fence-in part of the yard. The fenced-in area is a rectangular section of the yard that's separate from all other structures of the property. The family purchased 70 feet of fencing. What function models the area of the pen? So we want to get the area of the pen, which means we need a length times a width. So, ready? Here we go. Now, what I'm going to do is I'm just going to erase this because this, honestly, no offense, means nothing to you. This and this. All right? And even this. Honestly, it means nothing. So, ready? Let me explain. So you have a rectangular fence. All right, rectangle, bam. Now, what do you know about rectangles? Well, what you should have learned last year is that opposite sides are congruent. So I'm going to make that a tick and a tick. Notice they're different from the consecutive sides. Now, in this problem, you have to make one of your sides x, which makes the other side x as well because they're congruent. It doesn't matter which side you make it. I always end up making left and right x. Now, here we go. If we have 70 feet of total fencing, what I want to do is I want to take a step back and I want to say, all right, let's just say this. Let's say we knew what x was. So say we had just a fence and this is x. Come on, buddy. X and this is x. Let's say we have 70 total feet. All right. Well, here's the deal. Let's say we know x is 10, so x equals 10, right? If this is 10, this is 10, well, this has to be 10 too, right? If this is 10 and this is 10, what is left for these two sides? Well, you go 70 minus 10 is 50. 50 is left. Well, 50 feet is left for these two sides. You would go 50 divided by 2, and you would get 25 and 25. You see that? That's how you'd figure it out if you knew what x was. Well, let's go down here. Here's the deal. You don't know what x is. You just know it's x. So what we have to do is we have to work off the assumption that we'll eventually figure out what x is. So we have to go and say, all right, if we're going to know what x is eventually, and we know we have 70 total feet of fencing, we're going to say, all right, 70 is what I have left. But I'm going to go 70 minus whatever I know my values are. So I have an x here and an x here. So I got 70 minus x, because you're taking your total, minus whatever this side is, minus whatever this side is, to get whatever you have left, which when we did this problem, we had 50. Then, what did we do once we knew we had 50? To give each side a value, we divided by 2. So now we're going to divide the entire thing by 2. And what we can do is we can simplify this. 70 minus x is 70 minus 2. Oh boy, minus 2x. Come on, dude, this is a minus. Over 2. All right, and now you can simplify. Check this out. 70 divided by 2 is 35. And then, ready? Negative 2x divided by 2 is negative x. This right here, 35 minus x, is this side up here, which means 35. Come on, man. 35 minus x is this bottom side also. You see that? So, and that's just a simplified version of 70 minus 2x over 2, 35 minus x. So now, to find your area, area is length times width, so x times 35 minus x. We're going to distribute. We're going to get 35x minus x squared. And we'll want to simplify this and put it in standard form. So minus x squared plus 35. And then here's the deal. We have feet as our unit, so we'll go parentheses, feet squared, because that's your area. And there you go. That's simplified. So that is how you do this type of problem. All right, you got to make one of the technically two of the sides x, and then think, all right, if I have 70 feet, I got to subtract what I know, which is x, and then take your value and divide it by 2, because you got to give each set of sides an equal portion of it. All right, here we go. No, I got one more problem that I want to do. All right, it's very similar to that last puppy problem. This is on page 69. This, you're going to read and you're going to be like, oh my God, I totally know what's going on, but it's a little different. Ready? A farmer is building a rectangular pen using 100 feet of electric fencing. So electric fencing, wood fencing, whatever fencing. It's 100 feet though, okay, 100 feet. Now, ready? Here's the trick. It says 100 feet of electric fencing, and the side of the barn is being used as the side of your fence, and I'll show you with the drawing. In addition to the fencing, there will be a 4-foot gate also requiring electric fencing on either side. Honestly, that's silly. That means absolutely nothing. All right. That fencing, that's basically meaning that you're putting a fence that will have electric gate. So that doesn't mean anything. On either side of the pen. The farmer wants to maximize the area of the fence. So maximize the area. Maximize area. So we'll talk about what that means in a second. How should we make each side of the fence in order to create the maximum area? Now, ready? Number one, we're talking about dimensions. We want to know a width and a length. Additionally, when you hear the word maximum, what is that referring to? Yes, you called it vertex. So we're going to want to figure out what the vertex is of this function after we make it. So, ready? Here's the deal. 100 feet of fencing. It's rectangular, but one side of your fence is a barn. Ready? This is what this sucker looks like. All right, you see that? That's what this guy looks like. Now, you know what? I'm not a big fan of what that says in there. Don't like it. Where am I at here? Okay, ready? I'm going to make this easier on us all. We're not going to worry about the 4 feet of gate. So here we go. Ready? Number one. You have a barn. Here we go. Ready? B-A-R-N. That's being used as one side of your fencing. So technically, all right, this is congruent to this, to this, to this. Good Lord. and that's congruent to the barn, but that's not being used for electric fencing. All right. What I'm going to do is I'm going to make this distance x and this distance x. Ready? If you have 100 feet total, this third side is going to be 100 minus x, so it's actually minus 2x. See that? So that is your fencing right there. So x, and that's 100 minus 2x. That's what's left, because your barn doesn't use any of it. Your barn is just, technically it's 3 sides of electric fencing and then a barn that makes it a rectangle. So here we go. Write an expression that describes the length of each side. We did that. So now it says build an equation that describes the area. So we're going to go area equals x times 100 minus 2x. That's your area, length times width. So when you do this, you're going to get 100x minus 2x squared equals, right, your area. So at this point, all right, we don't know what the area is. We can't identify what that is. So what we're going to do is we're going to call this 0. All right. So we don't know what it is. So we're going to say it's going to equal 0 right now. That's what our area is. We're going to find our maximum area in a second. Or technically, you can call it y. All right. Oops, sorry. Y equals 100 minus blah, blah, blah. So I'm going to put this y equals negative 2x squared. Come on, buddy. 2x squared plus 100x. I'm going to put it like this in standard form. The reason being is because this is my area formula. Area. All right. Now, ready? To find the maximum area, like I said before, we should be saying vertex. So I'm going to go, all right, x equals negative b. Well, in this problem, you don't have a c. Your b is 100. So negative 100 over, man, come on, dude. I just want to go to bed. Let me go to bed. Come on. Negative 100 over 2a. So 2 times negative 4. I don't know why this is doing this. I'm like seconds away from just being like, whatever. There we go. So when we simplify it, it's going to be negative 100 over negative 4, which will simplify to 25. So we have an x value of our vertex of 25. So vertex equals 25, comma, something. All right. Now, how do you find your y value of your vertex? Because that's going to be your maximum. All right. You substitute it in. So we're going to go negative 2 times 25 squared plus 100 times 25. So here, 25 squared is 225. 225 times negative 2 is going to be 450. And then plus 100 times 25 is 2500. So negative 450 plus 2500 is 2005. So ready? Here's the deal. Use the x value from the vertex to find the length of the pen. Boom, done. So here we go. X equals 25. So our dimensions of our barn, remember it was barn, and then it was x, 100 minus 2x. So when we do this, this is going to be 25, 25, and then 100 minus 2x is 50. So it's 25 by 50. That's your, oops, 50. Those are your dimensions, 25 by 50. And then your area, your max area is equal to your y value right here. So 2005, and then I believe we were talking about feet squared. That's your max area, whatever your y value is. It's your y value from your vertex, 2005 feet squared. So here's the deal. Please go to the sub now, get your homework. It's a worksheet, front and back. I'll put the answers on Google Classroom. Please check that over. If you have any questions, I'll be in school hopefully on Wednesday, and we can go over any and all questions starting at 7 a.m. Have a great day. Be good to the sub.